Hi, so today I'm going to talk a little bit about Chapter 12. I'm going to talk first basically about the EOQ model and what it is, and then I'm going to move into working a little bit of the problems. So the first thing is Chapter 12 is all about inventory management models, and as I told you in class, these models are specifically designed to work best for items with independent demand. So with that in mind, what I want to do is turn your attention to the graph that you see there on your handout, but I'm going to have it a little bit larger on the screen. Here is the objective of the economic order quantity model. As I told you in class, the objective is to minimize total costs. Total costs are comprised of holding costs and setup costs, or ordering costs as we call them. So you notice there's a curve here. This is the setup cost curve, and then this is the holding cost curve, or it's not really a curve but line. And what we want to do is minimize these taken together. So the whole reason we do economic order quantity is to minimize both holding and ordering costs, or holding and setup costs. Now, this is based on the premise that we order our inventory and we slowly use it up over days, and then we order more. So as you can see here on this slide, this is the way it works. We make our order and it all comes in, and then we slowly use it up over time, and then we make another order, we get another order in, and we slowly use it up over time. So this graphic depiction, I think, kind of explains how the economic order quantity model works. This is why we compute inventory holding costs and the average inventory by Q divided by 2, and that's because we assume that the average amount of inventory we might have would be, where this line falls in the middle here. So with that sort of as a background, what we're going to do now is switch over to our handout, and we're going to talk a little bit about these problems and computing some of these numbers. Break. So now you see in front of you, first thing up here is these key terms. So the key terms are what help us write out our model. So it's important that you understand holding, inventory costs, those are designated H, shipping, ordering, setup costs, those are designated S, annual demand, of course in the economic order quantity model it's always going to be big D because it's annual demand, and then lead time. And the economic order quantity, and if we're using the economic order quantity, we call that the optimal quantity. So really there should be a star right here, so Q star. So let's just go down here to this problem. I tell you that the annual demand is 1,000 units, the ordering costs, annotated as S, are $10 per order, holding costs are 50 cents per order, and the place operates 250 days per year. So let's then go ahead and use this economic order quantity equation to put in those numbers, 1,000 here, and S is 10, and we're going to divide through by 50 cents, so 0.50. Oops, I left that H in there. And we know from class this is the square root of 40,000, or 200. So what is 200? 200 is the amount for which we should place our order when we need to order, and it is the amount that minimizes holding costs and ordering costs. So I'm going to write that out here. So I have just typed out what I just said. The economic order quantity, or Q star, the optimal order quantity, is 200, and it is the amount we want to order. It is the amount that minimizes both ordering, annotated as S, and holding costs. I'm going to make those just capital letters here. Okay, now let's move on down to B, part B. So now what we want to do is compute the number of orders, the time between orders, and the holding cost. So the number of orders per year is just going to be done as the total demand for the year, which we know is 1,000. We're going to divide that by the economic order quantity. So we divide that out and we find out that we're going to have 5 orders per year. And so this is 5 orders per year. Then the time between orders, again, we're just going to take the number of days we work per year, which I said in the problem up above is 250, and we're going to divide that by our 5 orders per year. And we're going to find out that we're going to get an order every 50 days. So we're going to put equals 50. So we're going to say, to interpret that, we receive an order every 50 days, working days, I guess I should say. So that's what that tells us. Now we want to do the total annual costs. And we compute the total annual cost by taking 2 equations, essentially. We do the annual setup cost, which is this part of the equation, plus the annual holding costs. So again, we just plug the numbers in once again, and we're going to take demand 1,000. We're going to divide that by our Q, which is 200. We're going to multiply it times 10 because that's our S, our shipping cost. And then we're going to take again our Q, our 200. We're going to divide that by 2 and multiply it times our holding cost of 50 cents. So let's go ahead then and type that out. Our demand is 1,000. We're going to divide that by 200. That's our economic order quantity. And we're multiplying by 10. And then over here we've got Q, which is 200, divided by 2. We're going to need to change that. It stays the same. And we're going to multiply that by H, which is 50 cents. And this is going to give us 50 plus 50, which is going to equal 100. So our total cost per year, without consideration of price, is going to be $100, and it's going to essentially be $100 for ordering and holding costs. So let's go ahead and type that out. So at the EOQ, or the optimal order quantity of 200, the total ordering and holding costs are, hold on, I need to move this up so you can see it, are $100, which is 50 for ordering and 50 for holding. Let me move that up again. Now, it's important that you understand that they're only equal when you order the economic order quantity. They're not equal if you, for some reason, don't order the economic order quantity. Which sort of brings me to the next page, which is where we talk about quantity discounts. So in example 2.2, we talk about quantity discounts. So here we have a little bit different calculation we have to do to figure out what the holding cost is. So first thing that's important is this IP here is the same as H. So we're going to calculate the holding cost as a percent of the price. So I tell you up here that a firm has an annual demand of 5,000 units, ordering cost of $49. Holding costs are 20% of price, and price is based on the purchase quantity. So if we purchase between 0 and 999, our holding cost then is 0.2 times $5, which will equal .1. And then here we have 0.2 times 4.8, so our holding costs are going to be 0.9. And actually I misspoke here, this should be 1.0 and 0.9, and I'm going to put a 0 in here just to be better. And then down here, I'll just change the font here, it's going to be 0.2 times 4.75, and I just saw that I had this as 0.5 and it really should be 0.2, so my bad there. So 0.2 times 4.75, which should equal about 0.8. So these are essentially the H's for the different price quantities. So first of all, we're going to calculate the economic order quantity based on the non-discount price, which is going to be $1. So we're going to use our economic order quantity model, and 1 will be in the denominator. So I went ahead then and plugged those numbers in. You can do it on your, you could have done it on your own, but 2 times 5,000, that's the annual demand, times the shipping cost divided by 1, and it should give us about 700. So when we place an order, we should be placing an order for 700, and we know that 700 optimizes the ordering and holding costs, which means it makes them the same. So now when we roll down here and we compute the total cost based on this economic order quantity, well then we ought to find that it is equal, the ordering and holding costs ought to be equal. So I went ahead and just plugged in the numbers like we had done before, but I stopped short of this PD. So I took the 5,000, the annual demand, I divided it by the EOQ and multiplied it times S. And then I added over here 700, which is the economic order quantity, divided by 2, so I have an average, and then I multiplied it times 1, because that's the holding cost. But we also have to do this part here, PD. So we need to do price times demand. So the price is going to be $5 if we buy 999 or less, and so since we're buying 700, we're going to substitute this for 5, because we have to pay $5 a unit because we're buying 700, which falls within that first price break, and we're going to multiply that times 5,000. And we're going to find that this is going to equal $25,700. Now, the only part of this that's a little bit different is this next part, part C. We have to calculate the total cost at the next price break. So what am I talking about? We go back up here, we find out if we buy between 0 and 999, we buy them for $5. But if we're going to buy between 1,000 and 1,199, well then we pay $4.80. So now we have to calculate our total cost again and see if it's worth it to go ahead and buy more. So let's just see how that works out. The demand's going to be the same, but now we're not going to order 700, we're going to order 1,000. Because we have to order 1,000 in order to get this next price break. But now our inventory is going to change, and our price, our inventory holding cost is going to change. Remember, it was 0.9 if we, remember up here, we calculated it and we have 0.9 if we buy it for $4.80. And so right here, we're going to replace this 5 with 4.8, and then that's going to change our cost. It's going to actually bring it down a little bit to $24,686. It doesn't go down a lot, but a little bit. And then we have to do the same thing one more time because we have one more price break. So we'll put that here. But now we can't buy 700, we can't buy 1,000, we've got to buy 2,000. because up here, that's what it says. In order to get this next price break, we need 2,000. So we buy 2,000, this changes to 2,000. You can see, obviously, the inventory carrying costs are going to go up, even though this goes down a little bit, but not a huge amount. And the price goes to 4.75. And so now this will change from 25,700 to 24,822. So 24,822. So you'll notice that it isn't actually lower than this one. So the best quantity to purchase would be here. So we want to purchase 1,000 at a time. Or said differently, it's best cost, if cost is our only consideration, minimizing holding and ordering costs, then we want to purchase 1,000 units at a time. Now, I really strongly suggest that you take a look at the problems in the text that have the quantity discount pieces to them. So I just retyped this, that the lowest cost is attained when 1,000 are purchased each time. But I also looked in my book just to see about the quantity discounts. And so problem number 1220 and 1224 are both quantity discount problems. And let me just see, 1213. No, I don't think 1213 is. So those are not really listed here. So I won't, ask any clicker questions on those. But problems like this would be 12.20 and 12.24 that I just kind of see off the top of my head. So to practice this, I would take a look at those things just to give a little practice for it. Okay, thanks for watching, and I hope you have a great day. It's actually kind of warm outside. Take care. Bye.